So far, the arrays we've been working with have been single dimensional. Now we want to work with multi-dimensional arrays. What we want to remember is that multi-dimensional arrays can be static or dynamic, just like single-dimensional arrays. Also, multi-dimensional arrays allow for the storage of a lot of elements. The number of elements that we can store in a multi-dimensional array is the product of the dimensions of that array. So for instance, if we look at a single-dimensional array with a size of 3, that means it can hold up to 3 elements. If we have a two-dimensional array with the dimensions of 3 by 3, it can hold up to 9, or the product of those two dimensions. Again, a three-dimensional, we have 3 by 3 by 3, and that can hold the product of those dimensions, or 27. Same thing with a four-dimensional, where we have 3 to the 4th, and that can hold up to 81 elements. Now, we do have a four-dimensional array here that can hold up to 81 elements. Actually, we can have it hold as many elements as we want to list. We can also have a single-dimensional array that lists just as many elements. However, even though we can have a single-dimensional array that contains just as many elements as a multi-dimensional array, at some point referencing the information in a single-dimensional array that large becomes impractical and time-consuming. Now, what we need to keep in mind whenever we're working with multi-dimensional arrays is that it's important to assign the values and call values from multi-dimensional arrays using proper references. So in this case, I have a value of 18. Perhaps I want to call it or I want to assign it to element 1 in a one-dimensional array. So I refer to element 1 in the array and I assign it a value. If I want to do the same thing in a two-dimensional array, if you notice I have the number 56 and I have a particular place that I want to assign it, I have to make the reference. So here I have what I refer to as rows and columns. So I have to go to row 2, indicated here, and I go to column 3, indicated here, and that'll place this value in that location within the array. Now in this case, this is just kind of a visual representation of the array. So if we go down to a three-dimensional array, and if we think of dimension 1 as rows, dimension 2 as columns, and dimension 3 as layers or worksheets, I have the same reference requirement. So here I have the value 91, and I want it to be located here. So I want it to go to the third layer, not layer 1, not layer 2, but layer 3. And then I want it to go to column 1, row 2. And that's where I place that number. So if I want to call that value back out, I have to make the same reference. So when we work with multi-dimensional arrays, we work with them just like single-dimensional arrays. We just have to keep in mind the additional requirement that whenever we either call a value or input a value into an element, we have to make sure that we reference the location properly. All right, this is going to be a general overview of using arrays in our code. The first thing we see is the compiler instruction option base. This affects all arrays within a module. When we declare an array and we don't specify the lower boundary is assumed to be 0. With option base, we can specify whether the default lower boundary is going to be 1 or 0. So in this example, I've gone ahead and set it to 1. And what that means is that whenever I declare an array, but I don't specify the lower boundary, the default lower boundary is going to be 1. I can also set it to 0. If I get rid of this option base statement, then the default lower boundary value is always going to be 0. Below that is the compiler instruction option explicit. And what that does is it requires that all variables within a module be declared. So next what we're going to do is we're going to move into our procedure. And in this case, I've named it array example. Below that, the first thing we do is we declare our arrays. Notice that we declare an array like we declare a variable. In this case, I've named the arrays to correspond to the number of dimensions each array is going to have. So D1 is going to have 1 dimension, D2 2 dimensions, D3 3 dimensions, and so on. The difference between declaring a variable and array are the parentheses. We can specify the size and dimension in those parentheses, but for this example, we're going to leave that open. Also, what I want you to notice is take note of the data types for our arrays. This specifies what type of data is permitted to be placed in the arrays. Below that, we just declare our variables. And down here, we start assigning values. So I'm going to go ahead and step through our code to that point. Here we see a redim statement. A redim statement or a redimension statement resizes the arrays to our specifications. Now in this case, I'm using the values here that I've assigned to these variables, and that's what I'm going to use to size our different arrays. This first array is a single dimensional array, and I've given it a size of 3. What that means is that this array's upper boundary is 3. Notice I haven't specified a lower boundary. Because I have my option base set to 1, this array has a default lower boundary of 1. Next, we have a two-dimensional array. Again, I set the size of both dimensions to 3. Because I have my option base set to 1, the lower boundary of both dimensions will default to 1. These conditions are repeated for the following arrays. Here we start loading the array. In this case, we're going to assign numeric values. Now, as I step through the for next loop, I move from one element to the next assigning values. So as I step through, I also step through the elements assigning values. For a single dimensional array, this is pretty straightforward. However, when we move to a two-dimensional array, I use nested for next loop functions to load it. This is because I have to load one dimension at a time. So let's see what happens as I step through this. So here I have a value of 1, and I'm at reference 1, 1, and I'm going to assign the value of 1 there. Next, I have a value of 2, and I'm at reference 1, 2. I'm at reference 1, 3. I have a value of 3. Now I move to the next dimension, and I'm at 2, 1, and I have a value of 4. So as I go through here, I assign values one dimension at a time. We're going to repeat this process for the 3 and 4-dimensional arrays, but notice the number of nested for next loops that we need to do this. So as I scroll up, you notice I have 3 nested for next loops, and here I have 4. Now for all of these arrays, I've assigned their dimensions a value of 3, or a size of 3. So each one of these has, like the single dimensional has a size of 3, two-dimensional has a 3 by 3, then we have our 3-dimensional 3 by 3 by 3, 4-dimensional is 3 by 3 by 3 by 3. What you want to keep in mind is that the number of elements that adds up to. The number of elements in an array is a product of all the dimensions. So what you do is you take the size of each dimension and you multiply them all together, and that's the number of elements that are going to fit inside that array. So for our single dimensional array, there's only 3 elements. For our two-dimensional, there's going to be 9. For a three-dimensional, there's going to be 27. And for a four-dimensional, there's going to be 81. So for instance, if I look here, I'm going to go ahead and run through this code until I get to the end. And let's see. So for this one, there's 27 elements. And here we have a 4-dimensional one. We're going to start off at element 0. And here we go. So here we're starting off at 1. Let's see how many we're going to have at the end. And at the end, we're going to have 81 elements. So hopefully this gives you an idea of how to declare an array, size an array, and load an array.